Have you ever, looked up at the night sky on a clear night and seen one of those streaks of light like flash across the sky?
Oh, yeah.
And maybe even, like made a wish on it, It's one of those things like as a kid you're always told to do. It feels like magic, you know.
It does.
But those shooting stars, as we call them that we wish upon, they're not actually stars at all, are they?
No, not at all. The name is very misleading. It's a small piece of rock or metal from space
Hmm.
called a meteoroid. And they're basically like little fragments of asteroids or comets.
Huh. Interesting. So it's like almost like cosmic shrapnel.
Exactly.
Yeah, that's a
Yeah.
good way to put it. And the thing that I thought was so interesting too is that, thousands of these meteoroids enter the Earth's atmosphere every single day.
Every day.
So there's a lot of stuff flying around out there more than we realize, I think.
Yeah, we just don't see it all.
Yeah, exactly.
Yeah.
So today we're gonna really do a deep dive into what these falling stars really are and why they burn up.
Yeah, let's figure out why they light up the sky.
Yeah, because it's really quite a traumatic event when you see it. It's very quick. But so what actually happens when these meteoroids enter the Earth's atmosphere?
So they're traveling extremely fast.
Yeah, I bet.
Tens to hundreds of thousands of kilometers per hour.
Wow, that's hard to even fathom.
Yeah, to put it in perspective, that's like dozens of times faster than a speeding bullet.
Jeez.
So that's a lot of kinetic energy.
So what happens when something's moving that fast and it hits our atmosphere? What's that interaction like?
So as it's traveling through the air, it's colliding with all these air molecules.
Mm-hmm.
And all this friction builds up.
Hmm.
So much more friction than we would experience here, walking around.
Right.
So it's like if you imagine an object trying to push through a really dense fluid
Right.
at impossible speeds.
I see. So it's that friction then that causes it to heat up.
Yeah,
And that's what we see as the bright light.
exactly.
Uh.
So it gets so hot that the meteoroid starts to vaporize and glow. And that trail of hot glowing material is what we see as a meteor or a shooting star.
Huh. And it's amazing that it happens so quickly. I mean, you're talking about.
Yeah, it only lasts for like a second or two.
Wow.
That's very quick.
So most of the time, these little pieces of rock, and they don't even make it to the ground, do they?
No, they don't. About 99% of them disintegrate completely in the atmosphere.
Wow.
Yeah, they just turn into dust, basically.
So they're just vaporized, essentially.
Yeah, and that dust is just like other space dust, from asteroids and comets and stuff.
Interesting. So it's really just a visual phenomenon most of the time. But
Right.
what about the times when a piece of rock does make it to the ground?
So if a larger piece survives and hits the ground, we call that a meteorite.
A meteorite.
And that gives us a really valuable sample of material from space.
Right, because we can actually study it then.
Yeah.
So that's really cool. So we know what they are. We know what happens when they fall. But is there anywhere on Earth where we're more likely to see them?
So meteors can fall anywhere on Earth, but you're much more likely to see them if you're in an area with very little light pollution.
That makes sense, because if there's a lot of light around, you're not going to be able to see a little.
Yeah, like if you're trying to see a tiny spark in a brightly lit room, you're not going to see it.
Right.
But if it's totally dark,
Yeah.
then you can see even the faintest little lights.
Yeah. That makes perfect sense. So what are some of the best places then to see these?
So the best places are usually rural areas, deserts,
Okay.
places that are far away from cities. The source material mentions the American deserts, the Australian outback, and parts of Africa and Asia.
Okay, so it's all about getting away from the city lights.
Exactly.
And I guess even though millions of them enter the atmosphere every day, most of them are just too small to see with the naked eye.
Yeah, or they happen during the day when the sun's out.
Oh, right. Of course,
Oh.
because we wouldn't be able to see it
Yeah.
unless it was a really big one.
Yeah.
But you also talked about meteor showers, which are like these cosmic fireworks displays. So what causes those?
So a meteor shower is when you see a bunch of meteors that seem to be coming from the same point in the sky.
Huh.
And that happens when the Earth passes through a stream of debris that was left behind by a comet.
So a comet's like going through space and leaving a trail of dust and rock behind it.
Yeah, exactly.
Yeah.
Like a cosmic litter bug.
And then when we pass through that, we get this meteor shower.
Exactly.
That's so cool. And these happen at pretty predictable times, right?
Yeah, they do, because the Earth is passing through the same debris field every year.
Right.
So we have the Perseids in August, the Leonids in November, the Geminids in December.
So if you want to see a meteor shower, you just got to mark your calendar.
Exactly.
Very cool. So this is all really fascinating, but I know some of our listeners might be wondering, are these things actually dangerous?
That's a good question.
Because we are talking about, rocks falling from space.
Yeah, but luckily most meteors are not dangerous at all.
Okay.
Because as we talked about, they're usually pretty small and they burn up completely in the atmosphere.
Right.
But very large meteoroids can be dangerous.
Okay, so it's possible but unlikely.
Right, it's extremely rare.
But if a large meteoroid did enter the atmosphere, what would happen?
So it could potentially explode in the air,
Oh, wow.
which would create a huge shock wave.
And if it hit the ground?
If it hit the ground, it would obviously cause a lot of damage depending on its size and where it landed.
Yeah, that makes sense. And we have evidence that these things can be really powerful, right? Like, what about the Tunguska event?
Yeah, that's a good example.
That was a pretty crazy event.
Yeah, so in 1908, in Siberia, a meteoroid exploded in the air,
Wow.
and it flattened millions of trees
Millions.
over a huge area.
Yeah, so they can be pretty devastating.
Yeah, they can be.
But luckily, we have people who are keeping an eye on these things, right?
Yes, there are scientists all over the world who are tracking near-Earth objects,
Okay.
which are asteroids and comets that come close to Earth.
So they're trying to give us an early warning if something big is headed our way. That's good to know. So to sum up what we've learned today, that magical shooting star that we see and wish upon is actually just a little piece of rock or metal from space
Right.
that's burning up in our atmosphere
Exactly.
because of friction with the air.
It's amazing to think about all these little pieces of space debris constantly bombarding our planet.
Yeah, it really makes you appreciate how dynamic our solar system is.
Absolutely.
It's definitely less mysterious now that we know the science behind it, but it's kind of more awe-inspiring in a way.
It is.
To think about these tiny things traveling across vast distances and then putting on this amazing show for us.
It's pretty incredible.
It is. So next time you see a shooting star, go ahead and make a wish.
Of course.
It's still a beautiful thing to see, but also, think about the science behind it.
Yeah, the science is pretty cool too.
So our deep dive today on shooting stars has got me thinking, what other seemingly magical events might have really cool scientific explanations?
Yeah, that's a great question.
I mean, there's so much out there in the universe that we don't understand.
Exactly. There's always more to discover.
So until next time, keep looking up at the sky and keep wondering.
And keep learning.
Yeah. And we'll be back soon with another deep dive into something else amazing from the universe.
Sounds good.